Ulikuwa nataka kitabu gani?
Siku hivyo iko sawa.
Zika. You're done with this?
Yes. Thanks.
Yeah.
Sure.
Kama umetoka tena.
Niko hapo. Limit. Hello and good morning, everyone. Hello and good morning, everyone. Hello, good morning, everyone. I wish to welcome all of us in today's webinar. My name is Sam Nderitu. I'm talking to you from the Biointensive Agriculture Center of Kenya here in Thika. And I am the director and founder of GBIACK. GBIACK stands for the Biointensive Agriculture Center, a center where we teach and educate farmers on agroecological farming systems that are sustainable, systems that are environmentally friendly, and systems that are adaptable by the farmers, and especially the smallholder farmers. I hereby wish to welcome all of you in this webinar. I hope that all of us are experts in the areas of soil fertility management. And so I'm not here as an expert, but I'm just here to share the little that I know and the little that I'm able to give out, and so that in one way or another, people can use the skills and the knowledge, and especially with the farmers. GBIACK is an organization that trains and promotes the Biointensive agroecological farming systems. And agroecology, we know that it's very wide. It's a system that everyone right now, people that are conscious about the environment, and especially farmers and farmer trainers, are talking about. It's a system that will take us back into abundance, and that is food production that was there before. Today's farming system, especially technological systems, are not sustainable. When you talk of the genetically modified organisms and hybridization systems, all those are not sustainable at all, because they are taking us into poverty, and especially smallholder farmers. Because the nutrients that are required in the soils are not sustainable. They're not sustaining the soil. Rather, they're destroying the same resource base that the farmers require, or the crop require, in order to do well and in order to grow. So I'm here to present to you a webinar by the title, Soil is a Womb. We all know that a womb is carried by our mothers, and I want to respect all mothers, the women that give birth to us, because it is not easy to carry a baby for 9 months and deliver. Even the delivery day is usually so hectic and painful. And so I want to respect all mothers, because we say mothers are, they carry everything. They are the creators, second to godliness. So soil is a womb. It is a womb because it gives us everything. when you're talking about soil, and especially arable soils, you are talking about the soil that gives us what we need. And I want to remind us that soil is the second most important natural resource for human survival, now and in the future. It is a natural resource that human societies and human beings and individuals must have in order to survive. I also want to remind us that over 95% of everything that we see with our own eyes comes from the soil. Over 95% again of all the food that we eat comes from the soil. But most importantly, over 98% of everything goes back into the soil. So soil is very, very important. Of course, the first most important resource on earth is you and me, human beings. So we must respect the soil. All right. Okay, I want to mute everybody so that we get to hear one another clearly. Soil provides a host of crucial services for both the people and the planet. It's the one that gives us all the food that we eat. It purifies all the water that we drink and use in our homes. It protects us against flooding and combats drought. It's also key to tackling climate change because it captures and stores all the carbon that is emitted in the atmosphere. The home of carbon is not in the atmosphere. It is in the soil because carbon is the one that gives us food. We look at how CO2 gets exchanged from the atmosphere to the soil as we go along. So it's very important for us to understand and learn about the soil that we use every day, and the soil that gives us food every day. The functions of soil are just enormous. The soil is the one that holds us, is the one that gives us life. It purifies water, it regulates climate change, it nutrifies, nutrients recycling. It's a habitat of almost more than 50% of organisms. It provides the construction materials. It gives us all the cultural heritage. And most importantly, gives us food. So soil is very important. As well, soil is a great integrator of everything. Soil can integrate with anything here on earth. It's also essential for natural resources. And so when you look at the soil as a media for crop production, some of the food nowadays is artificial. And we hear that there's food that comes from other places that is artificial. That is not food. That's a food, in quotes, that destroys our health, destroys our environment, and it poses lots of dangers into our lives. So we need to really get to understand and hold soil as a very important resource. Again, soil is a living thing. It moves slowly. You cannot notice, you cannot realize that soil is moving. I can put it like that. Soil is walking. It walks, just like human beings. It walks, it moves. It's changing and growing all the time. Probably from worse to the better or to the best or from better to worse. So it depends on how you hold that soil. So it's growing either negatively or positively. Just like other human beings, the soil breathes, and there's that gaseous exchange, just the way I am breathing right now, putting in oxygen and emitting CO2. The soil also needs water because I also drink water every day, even right now. I have water here because I need to rehydrate my body for me to stay alive. So for the soil to stay alive, also, it has to take water. Healthy living soils provides us with our everyday needs. So without soil, I can't live. You can't live. And that's a fact. So let's come to the topic of the day. Soil is a womb. And when I'm talking about soil is a womb, we are talking about 5 elements, 5 components. Air, we are talking about water, we are talking about OM, which is organic matter, we are talking about minerals, and you're talking about biota or biology. And these 5 elements must go together. If you remove one, then that is not soil. That is not arable soil. Because we have, the soil can be defined as, there are so many definitions of soil. But when we're talking about arable soils, we are talking about soils that can produce food, the soil that produces food and healthy food, not just soil. So a good soil has 5 elements: air, water, organic matter, minerals, biota or biology. And we are going to tackle each so that we get to understand the importance of each element. And please, if you have questions, you'll post them in the Facebook, and then we'll be able to answer as we go along. These elements are in percentages. And the biggest element, which has the biggest percentage, is of course the nutrients, because that's the food that's required by the plant at a particular time. Every time the crop or the plant eats, it eats from the soil. So the nutrients are the biggest in percentage. But nutrients come from what we call organic matter. And organic matter is the smallest in all the 5 components. It's only 5%. But now we are looking at how organic matter fits microorganisms and how the nutrients are derived from the organic matter. So there's what we call a dead organic matter, and then there's living organisms. Both collaborates, they work together, because living organisms eat from organic matter, from the dead organic matter, but both have to work together. And then we have air, which is 22%, and we have water, which is 22%, or 22.5%, around there. So, but no, all these components must work together for the soil to be called arable. So a good farmer must look at, how do I provide air into the soil? How do I provide water into the soil? How do I feed the living organisms or macro and microorganisms that are in the soils? And how do I provide nutrients to the plants so that I get to eat? So there's a correlation between soils and human beings and the environment. So we have to understand that. So we start with air. From A, we now have air from the word a womb. So let's discuss air and see what's the importance of air. The pores that are not filled inside the soils with water are filled with air. So if there's no water in the soil, what will be there is air. And we'll find out later as we go along that excess water is dangerous and excess air is also dangerous. So it must have a balance of water and air in the soil. It has to have a balance. So a mixture of 79% or 78, around 78%, 79% of the total gas or total air that is in the soil is nitrogen or even in the air. And then we have 21% of oxygen. And then we have CO2 or carbon, that is 0.2%. And this air is in constant exchange from the soil to the air, from the soil to the air. There is what we call diffusion. Diffusion is the movement of air from the high concentration to the lower concentration. So if there is a gas or air that is more, it has to look for ways to escape. So it moves from where it is in concentration and goes to where it is less. So it moves from the soil. From the soil, if there is one gas that is in excess, it finds its way to the atmosphere. And if another gas is in excess in the air, it finds its way in the soil. So there's that gaseous exchange. But we have a big danger here because we are emitting excess carbon in the atmosphere. And then, so we have to look at ways on how to capture this carbon and capture it, and so that we can return it back by force into the soil. And you know, as I've said, carbon is the one that gives us food. So that gas diffusion is very, very key. It's very, very important. So the soil is breathing. It's breathing because it needs all this gas in plenty within itself, and then it emits the ones that is in excess, just the way we are breathing. Breathe in, breathe out. So we have different gases that are present within the pores of the soil, and so between aggregates. So we have organic matter in the soil. We have some woody parts, some particles, some gravels. All those make aggregates. So there are pores inside there. So that's where the gas moves in, or the air moves in. So that gas is called soil air or soil gas. And so and as I've said, we have CO2, we have oxygen, we have nitrogen, we have methane, which is poisonous, and we have radon. So there are different types of gases. And there's that exchange. It keeps on exchanging as long as the soil is well kept. If the soil is not well kept, and especially if it's compacted, if a soil is compacted, there's very little movement of gases. There's very little of breathing of the soil. If there is excess water in the soil, again, that gaseous exchange is curbed. It's not there. So we must provide an environment that is very, very relevant. That's very it's good for the soil, for the gases to move in and out. And when the gases are moving in and out, it means that the crops are growing very well. So as I've said again, the pores that are not filled with water are filled with air. And that's the exact number now, exact percentages now of gases in the air. And that keeps on moving like that. So we must make sure that we maintain the balance between water and gases and air. Soil air is needed by many of the microorganisms that release plant nutrients, because what releases nutrients from organic matter are organisms. So they feed on organic matter and then they release nutrients that are available to be taken up by the plants. So microorganisms are important, also very important in the soil. But if the condition, the environment is not good for them, then they die. So gases are important. They are very, very important. So that now also microorganisms can be able to breathe. The soil is able to breathe, and there's movement of everything within the soil. And I'm giving a good example here of clay soil. When we're talking about clay soil, we have two types of clay soils. We have what we call one-to-one clays. One-to-one clays is a bit loose, with the bulk density is not so heavy. And then we have two-to-one clays. If you come to GBIACK, we have this what we call a heavy clays, which is a two-to-one clays. When it rains, we stop doing anything. There's no farming going on because it's not able to release that water quickly. So flooding is very quick. Just a little rain, then it becomes flooded all over. So there's no gaseous exchange. Gases helps water to escape. And I mean excess water to escape. So clay soils, if the drainage is not so good, then that kind of soil is not good for farming. But if the drainage is good, we know that clay soils holds natural nutrients. So if we make drainage so well, then the soils become so good for farming. And so that's a good example of when the water and the air is not moving in the soil. So how do we increase air movement or increase air in the soil? Number one, tillage. When you dig, you are temporarily, when you dig or till, you temporarily increase air spaces or even air and gas exchange in the soil. And now this increases activities of microorganisms and microbes and organic matter grows very well, and there's good environment for everything and even for crop production. So for us, we can use mechanical or animal-powered implements. You can plow using tractors or disking or harrowing or rototilling. But mostly we encourage human-powered. This is where you can deep dig, you can single dig as long as you're breaking the hard pan. You can do surface cultivation as long as the soil is soft. Because compaction or compacted soils reduce root matter, it reduces crop production, and it reduces organic matter. So we must make sure that at least we are digging, we are tilling the soil. The other ways that we can increase soil air is by adding manures. You can also balance the water in the soil. So that again helps to increase soil air. So 3 methods: tilling, 2 manures, and balancing water. That will increase the soil air. So how can we determine soil air mathematically? This is mathematical now. There's what we call bulk density. Bulk density is the relation between the mass and the volume of a dry soil sample. And this one, you can get it. You can do the simple mathematics. I know not many people like mathematics, but mathematics is everywhere. It's even in agriculture. And in agriculture, it's very tough. And so bulk density of the soil equals to weight of the soil divided by the volume of the soil. And it's typically expressed in grams per cubic centimeters. It tells us about the amount of air space that is there in the soil. Bulk density tells us about the spaces, air spaces, the pores that are there in the soil sample. So you can tell the soil density of your farm. So if the air spaces are tiny, then that means that there is compaction. Then we should cultivate, we should double dig, we should loosen the hard pan so that now air is able to go in and come out. The roots are able to penetrate and go and seek for nutrients out there. When you apply water, water goes down rather than spreading and causing flooding. Now, the world's agriculture soils have bulk densities that range from 1.0 to 1.8. And the average soils range between 1.3 up to around 1.6 there. That's the average. So when you're talking about low bulk density, low soil bulk density, you are talking about lower weight of the soil. When you scoop a soil sample and you want to understand the soil density, you are talking about the weight. So the lower the bulk density, the more the air spaces that are there. And then the higher the bulk density, the higher the weight of that soil. So there is less pores or less air in that soil. So the heavier a given volume of soil is, the more dense and the more compacted it is, and less air it holds. So we need to understand about soil bulk density. It's very, very important to any agriculturist or to any agronomist or agroecologist, so that we understand what kind of soil do we have, what kind of soil are we holding. Sandy soils have relatively high bulk density, of course, because they have less total pores, spaces, than silt and clay. And the bulk density increases as soil depth increases. So the more you go down, the more the bulk density. So in clay soils with good soil structure, and here at GBIACK we have for the last 15 years since we started cultivating this soil, which was, it was a very bad kind of soil. It rained like 2 millimeters and it flooded. And then after 2 days, you will find lots of cracks. But right now we have improved the soil, and improving a soil is not easy. It takes a long time of additional or continuous adding of organic matter, and not just organic matter, but good organic matter that has, has enough lignin. Lignin is woody parts that are not being digested very quickly. So you must keep on adding lignin or organic matter that has lignin that is not digested very fast. Because the type of compost that we make here is called cold compost. And cold compost decomposes very quickly. I mean, very slowly, within 6 months to 8 months. But it's the best compost because once you apply it in the soil, the organisms, the microbes don't use it very quickly because they release nutrients slowly by slowly. So it's able to last long in the soil. So we have to understand the type of organic matter that we apply in our soils. There's organic matter that's digested very fast, and some organic matter that lasts longer before it is digested. So what does soil bulk density tell you? If it's greater than 1.6, then it restricts roots from growing. If it's greater. Sandy soils often have greater bulk densities. Sandy soils, they have greater bulk densities than silt and clays. I think we have talked about that. So increasing soil organic matter decreases bulk density. That's what it tells us. So you increase organic matter, you decrease bulk density of the soil. And so you increase porosity and water infiltration. So that now when you apply water, just a little water, it's able to to be taken in very quickly. So if you know the soil texture, and we can do some experiments, which I have behind me. Either the jar method or the ribbon method. Then the bulk density tells us a little about the amount of organic matter in that soil. So bulk density can also tell you or help you decide if you should deep dig or single dig or just plant your crops without digging. So you can do some kind of conservation agriculture. If your bulk density is greater than 1.6, which restricts roots from penetrating down there, then you should double dig or you should deep dig. All right? Okay. So how do you measure? How do you measure bulk density? How do we measure bulk density? So there are equipments that you'll have, they're simple equipments. You need a ring, a metal ring, which doesn't matter the size because the mathematics will be calculated out of that. So a metal ring, you need a hammer. You need to understand how you will dry that soil. You need a weighing scale. And an optional, you need a blockboard or something like a timber that will hammer that ring into the soil. So determine where you are going to collect the soil sample. So you hammer that ring into the soil and then you pull it up, and then it will come out with that soil that is in that ring. And then make sure that the soil flushes, it's flush with the ring. And then now you'll do the mathematics. And of course, we know some mathematics, either I think in high school and in college, we did this mathematics of finding the volumes and finding the radius and all that. So the volume, take the volume of the ring, you'll measure. So it's pi r squared times the height of that ring. And so the volume is 3.114 as usual, and times, that is squared times height of the ring. And then you just put the numbers there according to how you have measured it. So that's how you find the volume of that ring. So this is the jar method. How you determine the kind of soil that you have and, you know, whether it has enough air or something like that. But the most important thing is to understand what type of soil do you have. So with me here, I have 3 types of soil, and one of them is compost. Soil that is rich in compost. It's not very visible because of the light, but I can see some 2 layers here. One layer starts from down here to here, and it is totally dark in color. It's blackish in color. And then there's another layer here, which is a bit light. And then this is water. And then on top here, there's trash. A lot of trash on top here. So this tells you that this is very fertile, because what is on top here, and you can calibrate this bottle. You can put on a ruler here and calibrate this bottle so that you are able to make your calculations. So that if this is from here to here is 10 centimeters, and then this is, for example, the dark part here maybe it's 5 centimeters, and then this one is 3 centimeters, and then you measure the truss that's up here, maybe it's one centimeter. You can do the mathematics and know the percentages of this part and this part and the part that is on top, which is trash, which is our organic matter. So that is one type of soil sample that I have collected, and it tells you clearly how it looks like. So this tells us that this soil is very, very fertile. Number 2, we have this other type of soil, and you can see the layer here is very small, it's very tiny. So it tells us that this soil is not so good because even the dark part is smaller, and then followed by this part here. And the colors here, they are not as dark as the compost that I've just shown. And this is the most important part here. This trash that's up here is very, very important. So you see that is small, and you're talking about the jar soil test method. And then let us look at this other one here. This is smaller as compared to the others, and this is bigger compared to the others. So this shows me that it's the poorest soil, and even the trash up here is tiny, is very small. So you can determine the kind of soil and the kind of fertility that you have and the kind of soil that you want. So the more the trash that you add in the soil, the more the compost you add in the soil, the better the soil becomes, because you're adding in more organic matter. And so that determines even the air movement in the soil. All right. So that's the jar method. And then we have the second one is the ribbon soil test. Ribbon soil test. So I'm going to gratify myself here just a little bit so that I show you the ribbon, how to determine the kind of soil. And so you collect all these samples, and then you need this. I'm gratifying myself, but I'm going to wash my hands. You need this soil like this, and you make a ribbon, kind of, and then you press as you go out. You press as you go out, like that. So it will tell you, according to what I've written there, the kind of soil. So I've just pressed once, and it has cracked. So this is clay soil. It has cracked. And you cannot proceed again because this one will fall. So this is called the the ribbon soil test. So you just need your soil like this. And any agriculture officer and agriculturalist should be able to understand the type of soil by it's very simple, and you will follow the procedures that are given. And this is also in the internet. You can be able to do that and just press like this, and you'll be able to tell, because you see it's cracking. It's kind of, the ribbon is cannot proceed depending on the kind of soil that you have. And then you also determine by the texture, that texture of that soil. So this is clay, it's very, very soft. All right. So those two methods are very simple, and one can be able to understand the kind of soil that they have in their farms, and also advise. If you want to change any type of soil that you have, it is possible. It is possible by adding organic matter. And organic matter cannot be added once. You keep on adding organic matter all through, every time, for many years. Because an inch of soil, for you to build 1 inch of soil, naturally, probably in the forest, it takes over 500 years. But you can reduce that time and take it for 6 years by adding enough organic matter in only 6 years, and you'll be able to improve your soil. All right. So number 2, let's talk about water, and that is component number 2. Very, very important, water. So I'm saying that soil organisms and plants need water for metabolism and for access to nutrients. And that is true even in ourselves. This body here requires water for better metabolism. and you are supposed to take up to 8 glasses of water every day, even more. The more water you take, the better your health. And we are told that medicine number 1 for us is water. The same applies to our crops. So once you apply enough water in the soil, you are able to feed the organisms that are there in the soils. There are millions and millions of organisms in the soil. We have bacteria, which is 80% of the organisms that are in the soil are bacteria. We have fungi, we have actinomycetes, we have, different. The ones that you can see are the ones that you cannot see by your naked eyes. So you have to apply just enough water. Too much water can lead to anaerobic conditions in the soil. So, and so you need to get to measure the amount of water that you're applying in the soil. If you have too much air in the soil, it leads to plant wilting. Too much, just wilting and death of the plants. If you have a little of it, again, it's a problem. So it has to be optimal. Those 2 pictures there show two farms. One farm that has good soils where crops are growing very well and there's balanced water. And the other farm is where there's no balanced water, so water just floods. And the crops cannot do well there. It's also good for us to understand the water cycle, how we get the rains from the atmosphere. It's taken up by the plants, and then the plants transpirates, goes to the air, and then there is flooding water, or in the seas or lakes, the water evaporates because it has been hit by the sun. It evaporates, it goes up to the atmosphere and condenses with the clouds, and then precipitates in form of rain. So that cycle is very, very important for us to understand. And the more the vegetation, the more the precipitation. If we don't have enough vegetation in an area, then it means that there's not enough rain. So we need to increase vegetation cover so that we get more precipitation. Those are 3 types of soils. That shows different conditions, especially when you apply some water. A good condition, when you apply water, the soil disintegrates. The other one, the soil might not disintegrate. And then the other one is compacted. So we need to grow our soils to the point that we have this kind. So that when we apply just a little water goes down, and the clods of the soil disintegrates. Those aggregates, they become loose. So again, we can determine the kind of soil by doing a simple experiment. Those are 3 jars with 3 types of soils. You have sandy soils, you have clay soils, you have loamy soils. And this kind of soils, it's very simple. You take a funnel or a funnel, and then you put cotton wool down there, and then apply the soil on that funnel, and then apply water. So the same you can weigh the same amount of soils in every funnel, and then the same amount of water. Again, applying the same. And then you see how water drops or percolates down there. And then you'll be able to say to see that sandy soils releases water very fast. So water goes just anyhowly. And then you have clay that releases water very slowly. It holds water on itself for a long time. And then loamy soils is balanced. Loamy soils are balanced because they have organic matter. They have the composition of sand, silt, and clay is balanced. The composition of sand, silt, and clay in clay soil is not balanced. Same applies to sandy soils. But the two, sandy soils and clay soils, can be improved, as I've said, by adding and increasing organic matter. You can take your soils from sandy soils to sandy loamy, which is can be also a very good type of soil. Those pictures there also shows us two types of soils and how the soil loses water through evaporation. So moisture is lost through evaporation from the soil surface, as well as transpiration from the plants and from the leaves. So you see, the first kind of soil, there might be two types of soils there. That could be clay, and the other one that has plants could be sandy soils. And so when just a little rain comes, sandy soils will be swept away, and especially if there is no crop cover or soil cover. Clay soils, again, will become mushy. When it dries up, it becomes cracky, it cracks up. Good soils will maintain its goodness all through. So we have to avoid compaction. We have to avoid letting the soils become bare, and we have to make sure that we are changing the texture of our soils and also the structure of our soils. So we advocate for good, sustainable practices. And one of the practices that I know that are very good is called Biointensive farming. And this system needs less water. It is not like conventional way of farming. It needs less water because we keep on adding organic matter. That is one. And we know scientifically that 1 kilo of compost is able to hold 6 liters, between 5 liters and 6 liters of water. So once you apply 1 kilo of compost in the soil, you are sure that it will hold 6 liters of water for you. And therefore that water will be able to grow food for you. All right. So that is how good Biointensive system is. And as I said, the more you add, the more organic matter you add in the soil, the more the water you hold for yourself. And not water in excess, but water, just optimum water for growing food. And actually, when there's flooding and you're practicing the Biointensive or any other friendly, sustainable practices, it's able to hold water for you for a long time, and your farming system, and especially when there's not much rain and with today's climate change era, these systems are resilient, they are friendly to the environment, and they give us, at least they give us some food, even if there's not much rain. But a farmer will say, yes, I am getting something from my farm because I'm practicing a sustainable method. So I would advocate for us to, anybody that practices conventional methods, to get back and think, sit and think the methods that are sustainable. And one of the methods that are sustainable is called a Biointensive farming system. And that's how it looks like. And the other way of conserving water is when you are covering your crops and you're using practices and principles that are very practical. And one of the practical principles in Biointensive is when you do close spacing after you have added enough organic matter and after you have loosened your soil and you have broken the hard pan. So that's, you can have that continuous planting of crops, continuous planting. It doesn't matter the season. When you visit GBIACK, we have crops throughout the year, and our land, our soils are never bare. They are never empty. They are always have something growing. And we practice crop rotation and companion planting, and we grow a lot of carbon crops. Carbon crops are crops that will give us materials for making compost. And so we have enough compost that we keep on putting back into the soil. And our compost comes from our soil. We don't get compost from elsewhere unless we are making something different. So water is important, yes, but it can change the environment around us. It can change the environment from better or for worse, and that is agricultural. So you can see those two farms there. One, this is called gully. Gully has started forming here because the land is just bare. There are no crops growing on the soil, and so this facilitates flooding. And after that, the gullies start forming, and eventually this land will not be arable at all. So it depends on us. How do you want our farms to look like? If your land is bare throughout, then it will look like this eventually. So we have to be careful on how we operate in our farms. Number 3, from the womb, we discuss organic matter. When I started, I said organic matter is the most important element. It's the most important component in the soil, the most important component. Because organic matter is the one that feeds macroorganisms, is the one that produces nutrients that are fed to our plants. Of course, organic matter in itself is not food for the plant. It has to be converted by microbes into a usable thing called humus. So from organic matter, it goes to humus, and then humus is now the food to the plants. This is what I normally say. Organic matter is food that is in the store, ready to be eaten tomorrow. But humus is the food that is on the table, is on the plate that you're eating right now. So humus is converted from organic matter, and organic matter is converted to humus by microbes. So a few facts about organic matter. Organic matter is critical for soil health. That is true. Organic matter is food for soil microorganisms. It also increases water permeability. I think I've talked about that. Organic matter comes from compost, and other manures. But we have to understand the differences between. Compost and farmyard manure. Farmyard manure comes from animals. That's why it's called yard. Yard is where animals stay. So you sweep the yard, and now you use that as manure. But there's great difference between the two. Compost is manures or fertilizer that is made out of crop residues and probably some dead animals or something like that. But mostly we focus on crop residues. Once that you have harvested, and then you lay them together, probably carbon materials versus nitrogenous materials. And so you lay them together like that. You can say mature materials versus immature. And if you want good compost, you must make compost with diversity of materials so that you get really rich kind of compost. So compost is supposed to contain lots of nutrients, but farmyard manure contains 1 or 2 or 3 elements. And the highest element is called nitrogen. And nitrogen in itself cannot be used directly. It has to be converted into nitrates or into nitrates for it to be taken up by the plants. And so it has excess nitrogen. I repeat again, farmyard manure from livestock, from say cows or goats or pigs or chicken, contains high amounts of nitrogen. But I want to let you know and understand that nitrogen, excess of it in the soil is poisonous because it causes what we call nitrogen toxicity. Nitrogen toxicity attracts a lot of pests and diseases in your farm. And so it is not the best. So you have to improve this farmyard manure by adding in carbonaceous materials. So add in carbon materials in your farmyard so that it improves and becomes almost equivalent to compost. And here we are talking about the carbon nitrogen ratio, CN ratio. The best CN ratio for your soils is 60:1. Probably you can start with 45:1. That is 45 parts of carbon and 1 part of nitrogen. You can start with that. And then you start growing slowly to 60 parts of carbon and 1 part of nitrogen. That will be excellent for your soils. So, in a nutshell, how do you measure the 60:1 materials so that you get to understand? The 60:1 materials tells you that, or tells us that 90% of the total materials must be mature. 90% of the total materials that will make the pile, and talk of a standard pile, which is 1.5 by 1.5 by 1.5 high, has to be 90% mature materials. Mature materials are materials that you have harvested. So they have put in flowers and they have put in seed. So you have removed the seeds. And then now the trash is the one that we are calling the mature materials. And then 10% of the total pile will be immature materials. Immature materials are materials that have not flowered. So they contain a lot of nitrogen. So you don't need a lot of nitrogen in that pile. You need just a little. And that is just 10%. So 60% to 1%. 60 parts to 1 part of CN. That makes a good compost. So we understand that African farmers keep a lot of livestock, so they have enough manure. They have enough farmyard manure. But our soils have kept on dying. Our soils are dead. And normally say that even some soils have been buried inside the soil because they don't grow anything. They can't grow anything. And that's why we keep on going back into the agrovets and the shops to buy inorganics or inorganic material, inorganic fertilizers to come in and supplement whatever we have, which is wrong. We do that because the soils are dead because of poor practice of the use of farmyard manure. And again, you must make sure that your farmyard manure that has been improved has totally or fully cured. It has cured. It has decomposted fully. Even the compost that we make, before it goes into the soil, it must be fully cured or totally cured. When you take the trash into the soil, you are kind of telling those materials to start the process of decomposition. So the microbes that are there in the soil, instead of them releasing nutrients to the plant, they start the work of decomposing those materials. And so the seed that you put around there will not grow well. So it will not have nutrients. So we must make sure that any material that we put in the soil is fully cured so that it just converted into humus immediately by microbes and the plants start taking the nutrients that they require. So that is important to understand. Soil organic matter facilitates soil aggregation, which increases airflow in the soil, providing oxygen and removing excess carbon from the atmosphere. Again, in our farms, we must make sure that the food that we are growing must be the food or the plants that will capture a lot of carbon from the air. The crops that we grow in our farms must be crops that are harvesting the nutrients that are in the atmosphere. And these are crops like maize, like amaranthus, like sorghum, wheat, oats. Those crops are called compost crops or carbonaceous crops. They help us to harvest the carbon that is in the air. And the total amount of crops, carbonaceous crops, that you should plant in your farm so that you say, I'm making good compost, enough compost in my soil, it should be 60% of the total farm. So 60% of the crops that you grow in your farm should be carbon crops, the ones that I've mentioned: maize, amaranthus, sorghum. We also have wheat, if you are growing wheat in your area. But you must make sure that you are growing crops, the crops that are growing very well in your farm. That's what you grow, so that you produce enough food. Right? And again, soil organic matter allows roots to move easily and to grow throughout. We also should understand that the upper part of the plant portrays the lower part of the plant. So the more vigorous the plant is growing, the more vigorous the roots are also growing. Yeah. Soil organic matter is a buffer. It neutralizes. Buffering means to neutralize. Neutralizes pH and stabilizes the soil environment. That's organic matter for us. It neutralizes soil pH. pH means potential of hydrogen. And the more the hydrogen in the soil, the more the acidity, the more the acidic that soil is. The less the hydrogen is in the soil, and you know hydrogen is always a plus. So the more it is in the soil, the more the acidic in the pH scale. So it goes from the lower scale. So it lowers the pH, which becomes dangerous for your soils. So the more the organic matter you add in the soil, it reduces the hydrogen ions. And so it stabilizes your soil environment. If the soil is acidic, just like this body here, if this body becomes acidic, it attracts dangerous diseases, including cancer. And it depends on what we eat. What we eat will tell us that whether we'll have cancer or not. Because if this body here becomes acidic, then it tells cancer, come, cancer, come. So we have to be careful, again, on what we eat. The soil and this body are equivalent. Soil organic matter again returns nutrients in the crop residues to the soil, and also it allows nutrients to be released slowly, just like dripping. The way the drip irrigation drips, the system drips the water. So it allows that drip. It releases nutrients slowly by slowly, which is very, very important. Not as the inorganic fertilizers, conventional ways of farming. In organic fertilizer, look at this picture here. I don't know whether you can be able to see my cursor. There's this picture on the right-hand side, and it tells us the differences between synthetic fertilizers and organic fertilizers. Organic fertilizers is converted into organic matter, and then it feeds the soil, and then the soil feeds, it also feeds microorganisms or organisms or microbes that are in the soil, and then it feeds the plant. So it's a process. But synthetics feed the soil directly. Yes, we'll get food. You'll get enough food, but resource base is destroyed. So we need to think, what is this that we are applying in our soils? Are we thinking about us right now, or are we thinking about the generations to come? So we should leave a place better than we found it. And our soil should be left better than we found it. Our forefathers left very good soils for us. And they grew a lot of food, healthy foods. And their life expectancy was very high. Right now, A Kenyan life expectancy is 40 years. So we are dying averagely at 40 because mostly of the lifestyle. And lifestyle number one is the way we eat, the kind of food that we are eating, and the way we are growing it. Because the way we grow it is the way we eat it. Imagine you're in a greenhouse. Greenhouse is enclosed. It's very hot. And you have a knapsack on your back and you're spraying a chemical. So you are spraying into yourself that chemical. So I want to warn you that the practice that you carry out today and the way you eat will determine your tomorrow. So this is how organic matter works. And this is the picture number one there is compost that has just been piled. So those are undecomposed materials. And then we go to the left, to the right. So those materials are in the process again. And you can see beneath there, the materials have already started to decompose. And then after decomposition, they form humus. And now humus feeds the plants. And that is the mandala there. The mandala that shows us the importance and the types of soil and the type of, how we are supposed to balance our soils. Living organisms, 5%. Fresh residues, 10%. Decomposing organic matter, which is active fraction, 33 to 50%. And then stabilized organic matter, which is humus, 33 to 50%. So let's have a balance, balancing everything within our soils. We have types of organic matter. We can derive organic matter from different sources. Number one is after harvesting. So those are maize tubers. You can decide to incorporate that in the soil after harvesting, just incorporate that in the soil. But there is that danger of microbes robbing nutrients from the soil as they do the work of decomposition. So yeah, it is good to incorporate those materials in the soil, but it depends on whether you are planting there and then, because if you incorporate these materials, this picture here with maize tubers in the soil, it means that it will take a while before the nutrients are available. So when you put a seed, maybe maize seed in the soil, the seed will germinate, yes, but it will germinate with purple colors, it will germinate with yellow colors, and it will take like 3 weeks or 1 month, 1 or 2 months, while it's still, dragging and with yellowing and purpling and all that. And then it becomes stunted. So when the nutrients are now available in the soil, it will start turning colors to green. But when a child is stunted, when they're still young, they won't do well when they grow up. So they remain just like that. Or they'll just improve just a little, but their health will have been affected because it was affected when they were still young. So yeah, that is one of the type of organic matter. We call it residues or crop remains or plant remains. Number two is animal manures. And you see this one here, it's good, as I've talked about it. It's good, but make sure that it's fully decomposted. And again, farm manures are good for perennials. They are excellent for perennials, but they are not good for annuals. An annual crop is one that takes like less than 1 year for you to harvest it. A perennial takes more than 1 year. So farm manure is good for fruit trees. It can be good for sugarcane. It can be good for bananas and all that. But it is not excellent for maize and unless you improve on it, you add in carbonaceous materials so that it has balanced nutrients. It's good. I'm not refuting, but let's understand science. The science is good. We have to learn about these things so that we don't regret later. And then we have roots. During harvesting, let us have that tendency of cutting, like the maize, like this maize, cut it from down there so that the roots remain in the soil. That one also adds in a lot of organic matter in the soils. And then, of course, now the best is compost. Compost is so good because it contains all the 14 elements all the 14 elements that are required in the soils. Of course, we have other fertilizers, organic fertilizers like bokashi. Bokashi is good as an amendment agent. It's for amending. It is not for building. Yeah, we have other types of organic fertilizers just for amending, like rock phosphate. It's good for amending the soil, but the agent for building the soil is well-built, cured compost. I think I've talked about compost crops, and those are some of them: maize, sorghum, amaranth. If you grow quinoa in your area, it's excellent. Rice, wheat, cereal rye, also very excellent. Barley, those are very good crops because they capture high amounts of carbon. And then when you decompose them, you take them by force into the soil. The best vegetable or crop in the world that is not very common here in Kenya or probably in Africa is called Jerusalem artichoke. Jerusalem artichoke is the best plant that captures massive amounts of carbon. And when you decompose it, it goes back into the soil with big amounts. All right. So the point down there, the last point down there, grow your own compost crops. It is very, very important because if you are an organic farmer or if you want to convert your farm from conventional to organic, you must make sure that you are using materials that are coming from your farm because probably you have not used chemicals. So when you return them back into your soil, you know that they are chemical free. But if you get materials from outside your farm, then it means probably that you don't know where they're coming from and you don't know how the crops have been grown. So let us have that tendency of starting to understand how to convert from conventional to organics. And it's very simple. 2 ways of conversion. I don't know how I'm doing in terms of time. I should end in the next 50 minutes. So I am doing well. 2 ways of converting your farm into an organic farm. Number 1, take a portion at a time. A portion at a time. So if your farm have been used to chemical fertilizers for the last 50 years, then your soil is acidic. It's very acidic. For sure, that one I know. And if you want to test your soils, there is an organization called EIPMA in Ruiru, Efficient Integrated Pest Management Association. They are based in Ruiru. They will test the soil for you at a very affordable cost, and so that you understand your soils. So test your soil first and know what type of crops or what type of soil you have or the crops that you want to grow in your area. So grow your own crops, compost crops from your farm and go step by step, portion by portion. So convert one portion first for 3 years, then go again, another portion 3 years. You can, the rest of the portion, you can continue using your own, the method that you have been using, but you know what you are doing so that in the next 10 years, the whole of your farm will be organic. And for a farm to be totally converted into an organic farm, it takes more than 6 years. For the soil to be tested, and they say, yes, for sure, all the residues, the poisons, the chemical residues have been removed because we say organic matter helps in removing, it seeps the poisons from your soils. It takes more than 6 years. So convert one section at a time as you move along. Number 2, use a system that I call half-half ratios. Half-half ratios. An acre right now in Kenya requires 100 kilos of inorganic phosphorus, or call it DAP for planting. It requires 2 bags of 50 kilos, 50-50, so that's 100 kilos. So first season, if you want to convert into organic farming, the first season, because now you have been using 2 bags, use 1 bag and add a lot of organic matter or compost or farmyard manure or whatever matter. So one bag has 50 kilos and quite a bit of compost. The second season, cut the 50 kilos into 25 and use 25 kgs and compost or farmyard manure. The third season, use the rest that had remained and then organic compost or organic fertilizers. So in 3 years, you'll have gone cutting by half until you remain with organics only. So when you use organics again for the next 3 years, and then you had tested your soils for residues, retest your soil again, and you'll find out that your soils will have converted into organics. And that's how I advise farmers. Go slowly by slowly. You cannot convert your land or your farm into an organic farm at a go. Because if you stop using chemical fertilizers at once and you say, now I'm an organic farmer from today, then you'll not harvest anything because the soils are used to those inorganic fertilizers. And so it's just like an alcoholic or a smoker, addicts. When they're taken to a rehab, they don't stop drinking at a go or at that time. They are given bits of alcohol slowly by slowly as it's reduced. So reduced method of operation. So that's how also we should treat our soils. And as I said, the soil is just like this body. If this body is used to one thing, it's really used to it. For you to stop using it, you have to reduce slowly by slowly until you stop using it completely. Yeah, so keyword compost and mulching. This is very controversial. Do we mulch our crops? Do we, because sometimes we use mulching so that we conserve water, which is excellent. And that's an excellent approach. But I put in red there that mulching conserves water, yes, but it's not always good because it takes up nutrients while it decomposes. So it robs nutrients from your plant. So your plant might not be able to get all the nutrients that it requires. So I advise farmers, these materials that you're using for mulching, make compost and use compost for mulching. So just scoop an amount of compost and mulch with it, because eventually that compost becomes nutrients. It is taken up by the plant, but at the same time, it's conserving water for you. And as I said, a kilo of compost holds 6 liters, between 5 and 6 liters of water for you. So I'm also saying that there is some evidence that you add more organic matter to the soil throughout composting residues in piles rather than as mulch. But this is not well studied. It is not well studied. But as you keep on adding compost as residues, it of course holds more water for you. I've talked about the CN ratio of a good compost pile or farmyard manure. The farmyard manure that has been improved is called Boma compost. Farmyard manure that you have swept from the chicken or from your cow's pen, from your goat's yard. When you add in carbon materials in it, it becomes Boma compost. Now it ceases from becoming farmyard manure. So when you use farmyard manure directly from the yard, that's farmyard manure. But when you add more materials, it becomes Boma compost. So get the difference about that. So this is organic matter when you look at it closely. So you can see that there's lots of residues, lots of materials down there, and there are organisms. You can see earthworms. You can see some microbes and some other organisms moving around. And when they're moving around, they're making tunnels inside there. And so they're making pores and at the same time improving the soil as they feast on those crop residues that are there and convert them from organic matter to humus. So that's how it looks like. So organic matter, in a nutshell, improves the soil structure, it improves productivity, it also increases biodiversity in the soil, it recycles nutrients, it stabilizes the soil, it filters pollutants, it retains water, improves aeration, and many other importance and advantages of adding in organic matter. And this is a practice that every farmer should be able to hold for them to really grow more food. It consists of components. These include a varying proportion and many intermediate stages, an active fraction including microorganisms, which is 10 to 40% of the total soil sample, and resistant or stable organic matter, which is 40 again to 60%, and which is now humus. 40 to 60% of the total is humus. In summary, soil organic matter feeds living organisms. It's materials that are partially decomposed and animals' residues. Again, is a potential food of organisms. It is transformed products, and then it becomes food and energy, and it's the one that holds nutrients. One important thing for us to understand is that organic matter is negatively charged. When it is negatively charged, it is able to attract positively charged nutrients like calcium, like magnesium, like most of the trace elements are positively charged. So it attracts and holds on itself like this. So it acts like glue. So when the roots are there in the soil and it's surrounded by organic matter, and the organic matter has held the nutrients, then the roots are able to take up those nutrients by two ways. One way is called by adsorption, to adsorb. To adsorb means that the nutrients are holding on the roots. They hold on the roots. They don't go inside, but they hold on the roots. So that is number one. Number two, they also absorb the nutrients. So absorbing means they go inside the roots. So first, because the nutrients are held up by organic matter, because organic matter is negatively charged, and the roots are around there, so they're able to take them on them for themselves. That's called adsorption, and then they're able to take them inside, which is called absorption. So it's organic matter is just that glue that holds that organic matter and the nutrients. Yeah, so yeah, so we go to the minerals from the word womb. I've said minerals comes from organic matter, which is transformed into humus by microbes. Microbes are very, very important, and they're the ones that do most of the work of the decomposition. Yeah, so they act as a source and a sink of essential elements, essential plant nutrients. They are the food, direct food that is taken up by the plants. And there are different sources of nutrients. Number one, organic matter decomposition. That's the big source of nutrients. Number two, precipitation is another big source of nutrients. Precipitation means rain. When rain comes from the clouds, it comes and meets different types of air in the atmosphere. One of them is nitrogen. And when there's that lightning, no, not thunder, but lightning. When the lightning goes and the rain is falling, it splashes nitrogen into the soil. So the rain in itself does not bring nitrogen into the soil. There must be some lightning. When you see that lightning and there is precipitation, then you know that automatically the nitrogen has been fixed into the soil. And you know, in the atmosphere, the highest amount of gas is nitrogen, which is 78%. So some of it is fixed into the soil by that lightning when there's precipitation. And then biological nitrogen fixation, that is using nodules from legumes. And not all legumes will fix nitrogen. It depends on that nodule, the bacteria that is in that nodule. Some bacteria don't fix nitrogen. And especially when you cut that nodule and you find out that it is whitish in color, you know that there is nothing there. It is not fixing. But when you find it's a bit colored, it's pinkish in color, know that there's a lot of nitrogen that is being fixed by the microbes, by the bacteria from the atmosphere, goes into that nodule, and then it's released into the soil. And now other plants are able to use those plants. I mean, to use those nutrients. And that's why legumes, in most cases, if the soil is just a bit fertile, just a bit fertile, you don't need to use any fertilizer to grow any legume. Legume is supposed to fertilize itself, like beans, like groundnuts, but it depends on the soil fertility. The level of fertility of your soil. If the soil is very poor, then no legume can fix nitrogen in that soil. So we can also do that experiment and see whether it is true or not. Weathering of rocks, of soil rocks and minerals. When rocks wither, sometimes you also harvest those rocks, like Beijing rock phosphate is a very good fertilizer that comes from the rocks. Yeah, like gypsum. Gypsum is a very good fertilizer that helps us to add into the soil, and we also get some phosphorus out of it. Yeah, and so yeah, and then I put in red inorganics, which I won't talk about because inorganics are useless. They are nothing to us. Any plant, any crop that we grow requires 17 elements. Any crop that you are growing in your farm requires 17 elements. And these 17 elements are very, very important. And so the 17 elements are required in the soil, and then now the plants takes it. The first 3 elements that are put in green, I call them HOC, H-O-C. HOC is hydrogen, oxygen, and carbon. These 3 elements, the plant will take them by themselves. It is not you to add. Not you to add them in the soil. They just look for them. That is hydrogen, oxygen, and carbon. The plant will just seek for them and look for them wherever they are, and they'll take them up. So that is not our work. Our work starts with the macro elements. NPK, nitrogen, phosphorus, and potassium. These are macro elements. The 3 elements that are required in very high amounts in the soil so that the plants can take them up. Those ones are called macro elements. They are needed and required in high amounts. Those 3. And then the second 3 are also macro elements or macronutrients, but are required in a bit lesser amounts: calcium, magnesium, and sulfur. Then the ones in yellow are called trace elements or micro elements: iron, molybdenum, copper, zinc, manganese, cobalt, boron, chlorine. They are required in small amounts by the plants. But all these elements are very, very important. There are some elements, if they are not present in the soil, for example, if boron is not present in the soil, then phosphorus will not work. I repeat again, boron, which is required in very small amounts, actually, the soil is tested, and when you test your soils, and you get the soil report, soil analysis, you can send it to me, and I can be able to analyze for you and tell you what you're supposed to do for that soil. So if boron is lacking in your soil, then phosphorus will not work, even if it is there. So all these elements are very, very key. They're very, very important. Calcium. We say that calcium is the handsome boy in the party. Is that handsome boy or beautiful girl in the party, where everybody wants to dance with them or they want them in the party. So they attract others. So that handsome boy attracts others in the party. So calcium is able to attract all these elements to itself. So in the absence of calcium, there is a big problem in that party. So call this, call it a party. So in the absence of calcium, there's a challenge, a big problem in your soil. Number one, calcium is the one that brings together elements. Number two, calcium is the one that gives us the aroma of our food, aroma in the plants. For example, call it onions or tomatoes. That aroma that is in onions, that aroma that chokes your eyes is brought about by calcium. Calcium is the one that helps the plants to flower. So it's very, very important in the soil. And each element there has its own work. There is one that helps in transportation of others that helps in absorption, others helps in photosynthesis. Yeah, so each has their own work. Yeah, organically and in agroecology, we are supposed to look at different sources. Where do we get what and what percentages? And we have everything in our disposal. We have everything in our farms. And that's why we say that we are resource poor. The resources are there, but we don't identify them. Imagine all this. We have cow manure. You see the percentages in nitrogen, phosphates, as phosphorus and potassium, horse manure, goat manure, sheep manure, and they are in percentages. If you want more nitrogen in your soil, which one do you apply there? You see, like poultry manure has high amounts of nitrogen. Yeah, rabbit manure has high amounts of nitrogen. So it depends on what you want to use there. Yeah, pig manure has some amounts. Human waste, we call it human manure, is the best manure on earth. And the future of soil fertility will depend on human waste. And that's the thesis. It is the best. It has 2% of nitrogen as compared to what I've displayed there. Look at that. We go to, yeah, look at those plants there. Tithonia diversifolia. Look at the nitrogen, 3.97. It's even higher than human waste. Look at Skajana Skajan. Skujana Skajan is a pigeon peas. Pigeon peas, if it is tender, when it's still tender, it has not flowered, it contains 3.62% of nitrogen. Jack bean, crotalaria, look at all that. Desmodium, soybeans. So if you're able to grow these crops, and we are looking for nitrogen, those are the crops to grow because they hold and they fix big amounts of nitrogen in our soils. Phosphates, the same. Potash, the same. And some of them don't have potash. So you are looking at what is it that you want in your soil. Boma compost, the one that I said, mixed of animals and plants. Look at that. Compost, it has balanced. Grevillea, banana stalks has a high amounts of potassium. Depends on what you're looking for. Yeah, so all that. Yeah, so we have all the resources with us. It's just that we need to identify those resources so that we can improve our soils. Lastly, last but not least, biota. And that's biology of the soil. When you talk of biology, you're talking about life that is there in the soil. And those are organisms, the microbes that are there in the soil. And we are going to talk one by one. And we have bacteria, we have fungi, we have algae, we have protozoas, we have nematodes. We'll tackle just a few and see how they work. Yeah, and so the more you improve your soils, the more the biology, the more the life that will be there in the soil. Yeah, so and those organisms, it doesn't matter which one, including moles, they have their work down there in the soil. They give us aeration. Some will bring nutrients that are down there, bring them up here, like the earthworms and other organisms. So they are very, very important. They go down and bring nutrients up. Some will destroy the soil. It will destroy the soil, yes, like termites. Sometimes they're not good, but they also have their work in the soil. So we'll look at that one by one in a nutshell and see how important they are: bacteria, fungi, actinomycetes, protozoa, and ratifiers. Bacteria, they're the smallest in all the organisms that are there in the soil. That's the smallest. 1 teaspoonful of soil, and I'm not just talking about soil, I'm talking about good soil. I'm talking about arable soil. It contains 100 million to 1 billion bacteria. Kijiko kimoja cha chai, 1 million to 1 billion bacteria. They consume carbon compounds. Their work is to consume those carbonaceous compounds. So about 80 to 90% of all the microorganisms that are there in the compost pile are bacteria. 80 to 90%. Fungi and actinomycetes and the rest are very, very little. They are very few. They are responsible for most of the decomposition. So most of the work of decomposition is done by bacteria. The rest come to finish, just to do the finishing work. And bacteria are of different shapes and sizes, and they keep on changing their sizes, their shapes, depending on where they are. Number 2, fungi. When you see molds growing, when you have food that have stayed somewhere outside the fridge, or they are going bad, you'll see some white stuff on top of the food. Those are fungi. Sometimes you see something like mushroom. All mushrooms are fungi. And both bacteria and both fungi, we have good fungi and bad fungi. We have good bacteria and bad bacteria. So there are fungi that you eat and some you not eat. When you eat them, you die. The yeasts, the molds, mushrooms, they're all in the same category. So during the decomposition process, when you pile up your materials, when you pile the materials together today, the decomposition process will start in 3 days. And the type of organisms that start the work of decomposition are these guys. They're called mesophiles. They are responsible for kickstarting the work of decomposition. And then now, after another 3 days, bacteria take over. So when temperatures are so high, the fungi live in outer sides. Fungi don't like high temperatures. And that's why mushrooms must be grown in cold areas, in cold room. So in a hot room, mushrooms cannot work. They cannot grow. So fungi break tough organic debris, like the woody parts, and especially the ones that are outside in the outer parts of the compost pile, because they don't go inside the pile. They also break cellulose and hemicellulose and lignins. I say lignins are those woody parts. And they can decompose materials too dry and too acidic or low in nitrogen, the ones that bacteria cannot work on. So you see, both bacteria and fungi are very important, because the materials that cannot be broken down by bacteria are broken down by the fungi. Actinomycetes. They are the ones that are responsible for finishing up. When you build a house like this, that finishing, putting it into what you want, is done by actinomycetes. So they come now to finish the work that has already been done by bacteria and fungi. They're the ones that are responsible for that ugly smell. When you smell compost, you feel, good smell. When it rains, there's that ugly smell that's caused by actinomycetes. And they also stay around outside the pile, most of them. And mostly also they feast on cellulose and lignin and chitin proteins are hard materials, hard bodies of dead insects or dead insects. It's called chitin. So they're responsible for finishing that and eating them up. So some species live also in thermophilic phase. Thermophilic phase means that they are high temperatures. They go inside also, and they can also help in the curing phase. The curing phase is the last phase of decomposition. So that's the work of actinomycetes. Protozoa, protozoa in our science is one-celled microscopic animals. They live in water droplets. So when you water your pile, those drops of water that hang, that's where they like living. So when you water your pile and there's drops of water that hangs on the materials, they go live there and start eating the materials. So they play a minor role in decomposition, not a lot of work, but they feed on organic matter, they feed on bacteria, and they feed on fungi. So when you see organisms, both macro and microorganisms in the soil, not all of them are going to eat on the organic matter. Some are going to eat on others. So they are able also to reduce the population inside there. So that's their work. And then finally, we have the rotifiers. They are very microscopic. They also find in water, those water droplets. They also eat on organic matter and bacteria. So when the decomposition has come to an end, then the compost has been cured, you are not supposed to leave it piling like this, because these guys, the rotifiers and the protozoa and actinomycetes, will start eating on the nutrients. So you must make sure that when the pile is ready, it's fully cured, you spread it so that it dries up. So if it's a little bit wet, then these guys will be present. And when they eat up the bacteria and the fungi, they will start eating up the organic matter. And then again, they'll continue eating even the nutrients that are there. And so they burn your compost. All right? And that needs us to really be careful about our composting process. So the roles of microbes, as I finish, beneficial soil microbes perform fundamental functions such as nutrient recycling. So their work is to recycle nutrients like this. Number two, they break down crop residues. They stimulate plant growth. While the role of microbes to maintain soil health and contribute to crop performance is clear, the soil biology is extremely difficult to observe and manage. So you have to really understand how the decomposition process is going, so that when your pile is ready for use, it's used. And also, where do you store your compost? How do you store it? Because some nutrients will evaporate when you store it in a place where it's raining. Some nutrients will be leached by the rain. And so whatever that remains becomes useless. So that has to be taken into consideration. And so I want to thank all of you because of listening to me. I want to give you some resources and show you some resources where you can be able to look for this information, some of the information. I did some 4 years research in 2014 to 2017. And that was a process of looking at the effects of one-time organic fertilizer application on long-term crop and residue yields and soil quality measurements using this system that we call the Biointensive system. And so it was done by myself and some two other guys from Cornell University and Elon University in North Carolina. And if you want to look at that study and how we did it, you can Google the PDF that I've written down there, FSUFS 0400667, and just put PDF there. Just the way it is there. Just you can just type the way it is, and you'll see that research. It was a 4 years research that I carried out here in Kenya, and I was assisted by the two professors from Cornell University and Elon University in Northern Carolina. And you have to understand, you'll understand the steps, how you are supposed to grow your soil step by step without using so much resources, and probably how you can move from inorganics to organics by using a single time organic fertilizers. When you're talking about organic fertilizers, we have organic fertilizers in the shop or in the shops that we buy. You can buy phosphates that are organics. You can buy gypsum, it's organic, rock phosphates and all that. They are there in the shops. But use them at the first time so that you try to fix the deficiencies that have been observed. And these you do after testing your soil. And then from there, you start growing your materials for making compost until you are now able to make your own enough compost for a particular area. And then you move again to another section. And so that's a very important research. Number two, you need to read. You have to read in books. Read. If you want to become a soil scientist, then you have to read. There is one book here called How Soils Work. How Soils Work by Paul. You can look at that. How Soils Work. It contains a lot of information about what I've talked about and all the elements that you require in the soils and how all the steps the soils work. This is another resource. It's called Regenerative Agriculture. Regenerative Agriculture is another very wonderful book that you can read. It has a lot of information on how you can regenerate your agricultural system. This is another big resource. It's called the ABC of Organic Agriculture. ABC of Organic Agriculture. So you can look at it online. You can order. I think most of these books you can get them from Amazon or wherever you can get them. And our manual here, our manual is called How to Grow More Vegetables. And we have How to Grow More Vegetables in almost all languages now. This is How to Grow More Vegetables in Swahili. So if you want to read it in Swahili, it's there. It's online. You just Google www.ecologyaction.org. Then you'll be able to find this. And it is in all languages. This is in Spanish for Spanish guys that are online. That is in Spanish. We have it in Chinese. Machinku ndio hiyo yenu. Machinku, that is yours. We have it in Arabic. In Arabic, yeah. We have it in English and in many other languages. So I wish to thank all of you for listening to me. And so I concluded that soil is a womb where it holds all our lives. Thank you. Unless there are questions, I take it over to Kennedy or PELUM.
Thank you, Sam, for the wonderful presentation. It was very insightful. There is so much to learn on soil health. I have noticed there are some questions in the comments. Maybe we can answer them. Let me try and read them. So one was from Jacqueline Maniki. She was asking, for those practicing organic matter, it is advised that we practice no-dig farming so that we do not disturb the soil microorganisms. What are your thoughts on this? Sorry, you're muted.
Yeah, no-till farming was established by a man called Mazibuko, and his idea was that you can do what we call conservation agriculture. And I think I've shown you a book here on conservation agriculture, where you after harvesting, you just make planting holes and you grow whatever you want to grow. Because with that system, then you'll not be disturbing the microbes and all that. But the current conservation agriculture that we have, that is promoted by some companies, and especially multinational companies that are promoting their chemicals, they say that you put something called a knapsack on your shoulders and spray and kill the weeds. It's called weed killers, like several weed killers that are produced by different companies, which are very dangerous, and they are cancer causing. So you just spray on your farm, and then you just plant. If it is conservation agriculture that I know, where you just harvest and then maybe you can do some hand weeding, I mean, just uprooting the weeds, and then you plant, that is excellent. And then maybe when you want to weed, you just weed on top here, the surface. That is excellent. I concur with her. But if it's the one that you spray chemicals like the weed killers, then I'm against that. The other question?
Yes, thank you. The next question was also from Jacqueline. She was asking, is it advisable to use shavings to farmyard manure so that we can derive the full benefits of organic matter?
Yes. I can say yes, no, and maybe. Yes, because wood shavings are carbon. No, because they can be from trees that emit some poisons, like blue gum, like cypress. They emit some poison that holds nutrients, and they make them unavailable to the plants. So you have to make sure that you know the kind of tree where the wood shavings are coming from. Yes, no, maybe. Maybe because you understand where the materials are coming from. Yeah.
Okay, thank you. The next one was, and I quote, I read somewhere that sunflower is good at removing toxins from the soil. Is this true?
Yes, it's excellent. It's a very good plant for removing some toxins from the soil. That is true.
The next one was not a question, but a comment. Congratulating GBIACK for the good work they're doing with encouraging good farming practices. Then the next one is another comment saying soybean is good at fixing nitrogen, but I will also check the color of the nodules. Thank you for this information. The next question was, what's your view on vermicompost and quantities?
Vermicompost it's for soil amendment. It is not for building the soil. So if you want to amend your soil, probably it rained so much, and then after raining, there's leaching took place. Then you want to turn back the nutrients. You do a quick fix. So vermicompost is for quick fixing. So the rate is a handful per planting hole or per plant. And then also we have the vermi liquid, the liquid that comes from that juice that comes from the vermi. It's called vermi juice. You can put a cupful per plant. If it's vegetables like sukuma wiki, like tomatoes, just a cupful, just to return back the nutrients that, just replacing the nutrients that have gotten lost.
Okay, thank you. Hosea says that a friend mentioned about the need to do charging of biochar. What is this and how is it best done at farm level?
Biochar is also a good system. For me, it's a good system, but when you burn anything, of course, you know what you emit. You emit carbon in the atmosphere. Carbon also helps in, or biochar helps in holding water. It holds water for you for a long time because it's charcoal. Charcoal helps to hold water. But now instead of burning those materials, why not make compost? And then that compost goes back into the soil. So you can do that. You can do biochar. It depends. Probably you have a lot of materials. But for me, I would rather do composting rather biochar. It is good. And all these are agroecological practices. But it depends on your belief and your science, because you have different sciences. So it depends on your science. It belongs on how you believe about it. Yeah. So if you're using biochar, it's good. And some people will look at it on a different dimension. Why can't I make compost out of it? Yeah.
Okay, thank you. The next question was, is it advisable to soak, for instance, Tithonia in water for a period of 2 weeks, then use it by diluting in water and irrigating crops, especially vegetables, with it?
I would advise that you dilute, you soak Tithonia diversifolia, which is tender, has not flowered, for 3 weeks. Those are 21 days plus. 21 days plus up to whatever time, but less than 3 weeks. If you test that water, it's not yet, it has no nutrients. So the best time is 21 days and above. Yeah, it's good if it is 21 days and above, and then you dilute it at a ratio of 1:1. 1 part of water, 1 part of the liquid and 1 part of water.
Okay, I think that was the final question from the comments. The rest are unanimous agreements that the presentation was very insightful. And maybe in case anyone in the among the participants has another question, maybe we should not lock you out. Please feel free. But otherwise, I think that's it. Thank you so much.
Thank you.
We still have a little bit of time. I have realized that we have not received questions on Facebook. So if anyone streaming live on Facebook, if you have a question, this is your chance before we close. Okay, I would like to thank everyone who has tuned in for this live stream. We appreciate your presence. We will have this recording for the whole webinar on our Facebook page, just in case you missed something, and also put a link to the resources that Sam has used. Thank you. Sam, if you have any parting shot maybe before we conclude.
Yeah, just to encourage all of us to get ourselves transitioning. let us transition, let us help our farmers transition from conventional to these sustainable ways of farming. It doesn't matter what kind of sustainable farming that you promote, but we need to let farmers understand that we are suffering right now out of lack of sufficiency, lack of abundance, because our soils are dead. For us to really grow food, we need to revive our soils. So farmers can use any means that is possible, that is affordable, so that they can be able to revive their soils. Can see a hand there, Gary?
Yeah, someone is asking how we can contact. Someone is asking how we can contact GBIACK. At Kennedy, maybe you can share the contacts or
Kennedy, you can share online.
Yeah. So for those who are joined here on Zoom, we have a very active social media platform, especially on Facebook. So I'll put a link to our Facebook page on chat so that you can also get other contacts, including our website and other social media platforms. Sam, Nderitu, we can continue.
So I hope that we got something from the talk, and let us take it and run with it and take it to the farmers, and let's help our farmers to become sustainable. Thank you.
Thank you so much, everyone, for tuning in. Again, we will have the recording of this webinar on our social medias and also PELUM. So it was great, and thank you so much, Mr. Sam.
Thank you.